Hi guys, today we're going to go through some practice problems on Hardy-Weinberg equilibrium. There's two equations. The first equation is P plus Q equals 1, where P represents the frequency of the dominant allele. So we'll use capital A. And Q equals the frequency of the recessive allele, or little a. The second equation is for the frequency of the three different genotypes. So that is P squared plus 2PQ plus Q squared equals 1, where P squared represents the frequency of the homozygous dominant. 2PQ represents the frequency of heterozygous, and Q squared is the frequency of the recessive individuals. Notice I keep saying frequencies. So we're talking about percentages here, percentages of alleles or individuals in the gene pool. So that's why they all add up to 1 or 100%. Let's do a practice problem. The problem that is on your the last slide of the notes page. So we'll set it up here. We're looking for, it gives you in the practice problem, it gives you that the allele frequency of the dominant allele, which is equal to 0.7. That's given in the problem. So up here, that's going to be our P value. Okay, so this is P. P equals 0.7. So we know that. Now we can use that information and this equation to find Q. So Q is going to equal 1 minus 0.7, which is 0.3. And that's going to be the frequency of the recessive allele in that population. The question asks to find the number of heterozygous individuals in the population. So heterozygotes are represented in this equation by 2PQ. So you're going to plug in these numbers to figure out what that frequency is. So 2 times 0.7 times 0.3, which gives you 0.42, or 42% of individuals in the population have the heterozygous genotype. The next one it asks you to look for are homozygous dominant. Which is represented by P squared. So P squared equals P 0.7 squared, or 0.49. And then finally we're looking for our recessive individuals, which is Q squared. So Q squared equals, here's our Q, 0.3 squared, which gives me 0.09. And if you add up these three numbers, they should equal 1. Okay, now do some practice problems on your own.